Uh, we discussed first two parts. Third part, which means part C, you have to find the expected value of this kind of function. Okay, hx is 2x minus 1. Okay, let's do this one. So this is part C. You have your function hx equals to 2x minus 1. Okay, you need to find expected value first. Expected value of hx. So at the time when I was doing the this expected value, I explain you how we use this kind of uh, function instead of just x. So expected value of hx, what is hx? 2x minus 1. So it is easy. You can simply assign expected value for each and every element in this expression. So expected value of 2 times x minus expected value of 1. Okay, so expected value of, let's say, expected value of constant equals to that constant. Yeah, so 2 is a constant, nothing to do with expected value, so you can write it 2 times expected value of x minus expected value of okay, I'll write it again, 1. So this becomes 1. So what is expected value of x? It is, I think you can find from part A. It is 2.85. Okay, so 2 times 2.85 minus 1. So we will get the answer for that. I think question number 6, the answer for that part. Let me find the answer. For that part, answer is 4.7. 4.7. Okay, next you have to find variance of this guy, this function. Okay, so same way you have to plug what it is, hx 2x minus 1 equals same here, expected value you can variance you can assign to, let's say x minus 1, you can assign to each of them, because the reason is this xi's are independent. Okay, xi's are independent, so you can here you can assign variance for each and every term, variance of 1. There is one more thing I mentioned in that period at that time, variance of a constant. What happened? Constant. Okay, variance of a constant equals what? Equals 0. So this guy right here equals to 0. There is no variance for a constant. Okay, so variance of 2x, once we have a constant, I mean a value with x with a variable, you can simply take this constant out, but once you take it out it becomes squared. Okay, so this becomes 2 squared variance of x. Okay, so you can find the variance of x from part A. It equals to 3.2275. So 2 squared means 4 times 3.2275. Answer is 12.91. Okay, clear? You can easily use these techniques, because I don't care which technique you use. I just need to see the answers. Okay, so this is the easiest way to solve this kind of problems. So this is the important thing you have to remember from this question. If you have to find the expected value of ax plus b, a and b are constant. A and b are scalars or constants. This becomes expected value of ax plus expected value of b equals to a times expected value of x plus expected value of b, plus b. So, okay, expected value of a constant equals to that constant. If you have like a variance of ax plus b, this equals to variance of ax plus variance of b equals a squared variance of x plus 0. So you don't need this equals 0. Okay, so this is the final result that you can get from this question. Okay, if you have any question, just talk to me or just use the chat. Okay, so I'm going a little bit fast because I need to cover this. If you have any question, please disturb me and ask the question. Okay, okay, question number 7. Question number 7, what kind of question is this? Question number 7. Okay, question number 7. Suppose that 30% of students want to buy a new copy of textbook, okay, for a particular course, and 70 buy a used copy. New copy and used copy. Okay, consider random selected 25. What kind of problem is this? Which distribution you can use? Definitely it's a discrete case. Okay, suppose that this 30% means 0.3. Students want to buy a new copy of textbook, and 70% buy a used copy, which means 0.7 used copy. So you have only two outcomes, new copy and used copy. So if you have two outcomes, it is a which kind of problem? It is a binomial problem, which means you have to use binomial distribution. So here n is 25. Probability of success. I define probability of success is new copy. Okay, I define probability of success is, success is new copy. My success is buying a new copy. Okay, so my P is equals to success probability equals to 0.3. Okay, so part A asks what are the mean value, and the standard deviation. Okay, so what is the mean and expected mean and variance of this binomial distribution? So you have binomial, so let's say X has binomial distribution with probability 0.3 and n is 25. Okay, so what are the expected value or mean? Expected value of this distribution is n times p. Your n is 25 times p is 0.3, so this becomes 7.5. What's the variance of this distribution? N times 1 n times p times 1 minus p. Okay, actually you need to find the standard deviation. So first find the variance. So this becomes 25 times 0.3 times 0.7. Okay, you need the square root of variance because you need the standard deviation. You need the standard deviation, which means variance of x, square root of variance of x, 0.7 square root. This becomes 2.29. So these are the two answers. Okay. Uh, this expected value and variance, they look like this because this belongs to binomial distribution. Okay. What is the probability of having at least 3 students buying a new copy? At least 3 students buying a new copy. At least 3 mean it can be 3 or more. So probability of x is my buying a copy. Okay, x at least 3 mean minimum can be 3, but maximum any number. X probability of x greater than or equal 3. Right? You can rewrite this like 1 minus probability of x less than or equals 2. Why this become less than or equal? Because these are discrete numbers. Okay, so less than 3 mean less than or equal 2. Okay, because copies are like 0, 1, 2, 3, whatever. Okay, something like that up to n. Clear? So you can find this using binomial table. There are two ways to find solution for this particular problem. So first one, I'll use the first option number 1. Okay, using binomial table. From your appendix you can find this table. So I need to find binomial, I mean b, what's the value? 2. Okay, 2. What is n? 25. And what is the probability, success probability? It is 0.3. Okay, I need these 3 values to find the particular CDF value, which means cumulative density value. Okay, because this is less than, it is something like this. Do you remember this one? Okay, it is something here it is 3. I need to find this probability from 0 to 3. So you have to go to the binomial table and find this value. Okay, I can show you that. I think you can see this screen. I also share this one. Let me find the binomial probabilities. Okay, you have this. Right, first one, binomial. Cumulative binomial. Okay, n is 25. So you have to find first where is n 25. Yes, you can find the n 25 here from this table. Okay. Then you know what is this? This is 25. Okay. This value is 0.3. This x is what? 2. Okay. So you can find x values from this first column. Okay, so x value 2, this is your 2. Then your success probability from this right hand side. So success probability is 0.3. 0.3 is here. So your value is 0.009. Okay, 0.009. Okay, let me go back to the. Okay, so this value right here, probability of x less than or equal to is 0.009. Okay, so now you can find the answer. Let's say this one, number 1, equation number 1. So from 1, probability of x greater than or equal 3 equals to 1 minus, what is this value? 0.009. which means 0.991. So this is the probability. Okay. Okay, this is that's the option number one. Next one is option number two. Is option number two. This one. Using binomial distribution. Binomial distribution. Okay. Do you remember the binomial distribution, which is probability of x equals x, which is nx. Something is going on. Probability of success to the power x 1 minus p to the power n minus x. This is the binomial distribution. Okay, so you can use this to figure it out what is going on here. So again, you need to find probability of x greater than 3, which means 1 minus probability of x less than 3, right? Same thing, it is equals to 1 minus probability of x less than or equal to, right? Because these are discrete values. Less than 3 mean less than or equal to. Okay, so you can find again this piece right here using binomial distribution. So less than 2 mean you have to start from 0, 1, 2. Okay, okay, which means n equals, okay, 25, x is 0. When x is 0, probability of success is 3 to the power 0 times 1 minus 0.3 to the power 25 minus 0. This is for probability of x equals 0. Plus, you have to sum from 0 to 2. Okay, probability is from 0 to 2. So 25, x is 1. So 0.3 to the power 1. 1 minus 0.3 to the power 25 minus 1. This is probability of x equals 1. Plus last one, 25 to 0.3 to the power 2, 1 minus 0.3, 25 minus 2, x is 2. Okay, see, n minus x. So this belongs to probability of x equals 2. Once you calculate these values, you can get 0.009, same value. Okay, so again from 1 you can simply assign these values. Equals 1 minus probability of x less than or equal to is 0.0009, and it is 0.991. So there are two ways to find this kind of problem. If any case you cannot find the probability, corresponding probability using binomial table, then you have to use this option number 2. Okay, because binomial table there are limited number of values, n equals 5, 10, 15, 20 and 25. So your value is not there, then you have to move to this second method. Okay. Okay, question number 8. The article expectation analysis of the probability failure for water supply pipes. Okay. Suppose that for a cast iron pipe of particular length, the expected number of failure is 2. Okay, expected number of failures is this much. Okay, then x is the number of failures. X is the number of failures. Has a, okay, they have given, has a Poisson distribution with parameter equals mu equals 2. So do you remember the Poisson distribution? So I'll write it for you. X equals x. Still we are discussing discrete distributions. Okay. Mu x e to the power negative mu divided by x factor. Okay. So x where x equals 0, 1, 2, whatever. There is no limit for this. Okay, mu mean the parameter. Okay, so first okay, the same time I'll tell you this one. Expected value of Poisson distribution is okay. It is this parameter mu, mean parameter. This is the mu. The same value you can see this 2 and this 2, which mean the same value. Expected number of failures. So here it is expected number of failures. So expected value is mu, which is equals to 2. Okay. So variance for this distribution, it is also mu, which means 2. So standard deviation, which is square root of variance, it is square root of 2. Okay. So it is easy for this distribution. Everything is mu. Okay. Part A. Obtain this much x probability of x less than or equal to, and second one. Okay. This one, yes, this is a cumulative probability. Okay, cumulative probability less than 2, probability of x less than 2. You have to add whatever from 0 to, because it start from 0, x is start from 0 to 2. Again, you can use this Poisson distribution table to get the value, or you can use option number 2, same as the last question. There are two options. Option number 1, you can use the Poisson distribution table, cumulative Poisson table, or you can directly apply the Poisson distribution to solve this problem. Okay, I'll use the first one. This is going to be summation I from 1 to 2, sorry, I from 0 to 2. Here is 0 to probability of x equals x. Okay, which means probability of x equals 0 plus probability of x equals 1 plus probability of x equals 2. These three. Okay. Okay. First option number 1. Option number 1. We can use table. So go to the table and find the corresponding value for this one. Using table, you can directly find this value. This means from our notations, you can write 2, 2. Okay, because this is the x value and this is the parameter mu. Okay, okay, I'll show that anyway. Poisson. What is this? Poisson. So x is 2. Your value is 2. It's not this table here. It is here. See, in the next table. X value is 2. Your mu value is 2. So corresponding value is 0.677. Okay, 677. So let me get the full screen. Okay, okay. So from the table, we can get value is 0.677. Okay. Option number 2. Probability of x less than equal to, which means you have to add these three. Okay, so you have to plug x equals 0 and find that probability, then then plug x equal 1, find that probability, finally find the probability of x equal 2 and add those three together. So let's do this one. 2 to the power, so I'm using this distribution. Okay, mu is 2, x is 0. E to the power mu is 2, x is 0, plus second one, x is 1. 2 to the power 1, e to the power negative 2 divided by 1 factorial plus 2 to the power 2 e minus 2 divided by 2 factorial. Okay, uh, factorial 0 is equals to 1. Okay, factorial 0 equals to 1. So no problem with this denominator. Once you solve this or simplify this, you will get the same value. Okay, so it doesn't matter which option you use, you can still get the same answer. Okay, question number 9. Okay, now we have come to the continuous case, continuous variables. We have been given a function right here, and also they have mentioned function has a this this function has this value for this particular range. Okay, this particular range for x, and also another value otherwise. Okay, so you can see if I draw it, my x-axis is this. So my 4 is here, 2 is here, including 4 and 2. This has a this function k times 1 minus x minus 3 to the power 2, this function. Whatever outside, which means from here to here, these two, the value is 0. Okay, that's the idea behind this function. Okay, it has that value exists in a particular range. Okay, part A, we have to find this k value. K value means this guy right here. Before you do that, let me remind you what is the condition a function, a continuous function should satisfy. Okay, which mean properties. Okay, do you remember these probabilities? Function of x greater than or equal 0. The other one is integration sorry, integral from its beginning to end. Okay, let's say in general, let's say negative infinity to positive infinity, fx dx, which means the summation is equals to 1. Area under curve, do you remember? Area under curve equals to 1. Okay. Okay, these are the properties of this kind of distribution, continuous distribution. Okay. So part A asks calculate the value of k. You can find k using this second property. Okay, you know what is the limits. This goes from 2 to 4, right? In your case, it is not negative infinity to positive infinity. It is starting from 2 and from 4. So fx is k times 1 minus x minus 3. Let me scroll up, squared. Okay, dx. What is this? Equals to 1. Using property number 2. Using property, properties. I'll say using properties. Okay. Okay. This is equals to 1. Then what you have to do? It is easy. You know how to do it, how to deal with this, right? Once you get the integral, once you integrate this, you will get this is x minus 3. Since this is 2, this becomes 3 divided by 3. Okay, from 2 to 4 equals 1. So anyway, k is a constant value. Okay, k is a constant value. So isolate k to do the cross multiplication. Just first plug these limits, upper bound and lower bound, and simplify this. You will get k equals 3 over 4. Okay, then you can find, you can what is yeah, it is just this is the answer. You need to find the k. Next one, obtain the cumulative distribution, cumulative function, part B. So to find the cumulative, okay, fx, what's the cumulative mean? In a continuous case, this is the cumulative. So cumulative, this is your x, 0, 1, 2, whatever. It's going like this, right? Maximum is 1. So I don't know any point, it goes to 1. That's it. Then it is remains same at 1. Okay. So fx, you can find, let's say, consider a common case like x, this x. So you can find this cumulative distribution from here to, from its beginning to this x by integrating it from negative infinity to x. That's a general way to solve this. Fy, let's say this is fy dy. Otherwise variable will mess around here. So I'll use y. Okay. But in your case, you know it start from 2, but you don't know it the upper bound is 4, but once you need to find the cumulative distribution, you have to use x. Okay, so you know what is k. K is 3 over 4. 1 minus, this is your function, 1 minus x minus 3 squared, right? Squared. Then dy. Okay, now you can simplify this and find the distribution for this. So this becomes like 3 over 4x minus x is x cubed minus 9x squared plus 27x minus 27 divided by 4 minus 7 over 4. Okay, so you can simplify this again. Negative x cubed minus 9x squared minus 24x minus 20, plus 20 divided by 4. Okay, so you know the range of x, which is equals to 2 to 4, right? Okay, so this exists, this one right here exists within this range. This is x range. Okay, so fx cumulative distribution, I can write this value right here, negative x cubed minus x squared minus 9x squared minus 24x plus 20 over 4 exists x less than or equal to greater than x greater than or equal to less than or equal 4. Is that correct? What happened after this? I mean, what happened less than 2 and greater than 4? So you know this this function whatever exists only from 2 to 4, right? What happened here and here? Okay, let's say x x less than 2, less than or equal or less than 2, whatever, it doesn't matter, since it is continuous, doesn't matter. And what happened when x greater than 4, which means this side? What happened? Less than 2 value is 0, because less than 2 it doesn't start, it starts from 2, so up to 2 it is 0, then it starts, right? So after 4 what happened? Let's say 4 is here. When x equal 4, it reached to its maximum value, which means 1. After that, I told you it remained same. So after that, it is 1. So you can write your cumulative distribution like this. So this is the answer. What is the other one? Part C. Uh, Calculate x less than or equal 3. Calculate x less than or equal 3. Okay. Part C is probability of x less than or equal 3. Okay. Now there is no table. Simply you have to use your integrations and those skills to solve this. Less than or equal 3. So x in this limit, right? X in where? X is 2 and 4. So this is something less than or equal 3. Let's say like this, start from 2. So 3 is here, 4 is somewhere here. So you need to find the cumulative probability from its beginning to 3. So easily you can find the cumulative distribution what you have taken above. Okay, so x in your range. So you can use your uh, F3. Simply plug x equal 3 into your previous this one previous equation here when x in 2 and 4 range. Okay, so -3 cube plus 9 times 3 to the power 2 minus 24 times 3 plus 20 divided by 4. It is plus, right? Yes. Oh, sorry. This is going to be plus, plus, plus. So this minus become plus. So this is going to be plus. Sorry about that. It's just plus. Okay. This becomes 0.5. Okay. So what is D? Expected value of x. Okay. D. Expected value of x. What is expected value of x? How do we find that? You have to integrate from 2 to 4. Okay, I'll write a general term expected value of x. You can find from its limit from negative infinity to a positive infinity, x times probability of x equal x. Okay, or x times its function, whatever, dx. Or this is your function, x times your function, dx, x is here. Okay, so same here, 2 to 4, 3 over 4. Sorry, I'll write it in this particular order. X is just x times 3 over 4. It is your k. 1 minus x minus 3 to the power 2 dx. Once you simplify this, your expected value become 3. Okay. Any questions? Any questions up to this point? If I give you a question, definitely it looks like this. I mean, if I give you a question from this continuous variable case to find k and then work with those cumulative distributions. So questions that order can be like this. Question number 10, it is based on normal distribution, right? X has a normal distribution with let's read this mean this much. So your mean gonna be 46.8. What is the variance? Standard deviation is this much, so 1.75 squared. Okay, what is the probability? The maximum is at most this much. So part A, at most probability of x less than or equal 50. This is at most. It is a normal distribution based question. Okay, so you can find it probability of first. What you have to do, you have to standardize this. Okay, so x less than or equal 50. So you know how to standardize this. Minus mu divided by sigma. Minus mu is 46.8 divided by sigma 1.75. Okay, this means probability of this become your C. C less than or equal 18.3. Go to the C table, find the probability of this. Find the C score for this particular. Find the probability based on this 18.3. That probability is 0.9664. Okay. But they ask the probability, so it doesn't matter. This is the answer. Okay, I think I can finish this real quick. So part B asks what is the probability the maximum is with at least 40. So probability of x greater than or equal 40. Same way, it is x minus mu divided by sigma greater than or equal 40. 40 minus 46.8 divided by 1.75. Okay, this means probability of C greater than or equal negative 3.89. Okay, once you need to find this value, you will see that. Okay, you will see that this equals to 1. Okay, greater than 40, you will see that value equals to 1. Please check this. You will see it is 1. Once you go to the C table, I'm not going to show you the C table because we have done so many times. You will get boring because I use the C table. So please check it. Okay, 75th percentile, which means 0.75 percentile, whatever up to this point. This is your 75%, 0.75. So you have to find the C value. Okay, have they given 75th? No. You have to find this particular C value based on this 75. Go to the C table, find the C value corresponding to, find C value corresponding to (0.75). Okay, that value is 0.76 from C table. Okay, so reverse process, x equals mu plus C sigma. Answer is 47.97. Okay, how you get this? X minus mu divided by sigma equals C. So cross multiplication, you can get this equation, and this is the answer. Okay, because we find everything using standard normal, then convert it to a normal distribution.